Hello, today we're going to be doing Inquiry 6.1. We're going to be using simple models of plate movement. Our question for this lab, how do the lithospheric plates of the Earth move? So think about the plates of the Earth that make up the crust of the Earth. If the plates of the Earth blank, then they will result in blank landforms. So let's think about how the plates of the Earth might move. We talk about how they might move together, and those are convergent plate boundaries. How they might spread apart, and that would be divergent plate boundaries, or the places where they might slide back or forth past each other, and that would be transform plate boundaries. So if the lithospheric plates of the Earth separate, collide, or slide past each other, what kind of landforms might they result in? Well, if they collide with each other, they might form something like a mountain range. If they separate, then they might form a trench. And if they slide past each other, they could form cracks and crevices in the earth. They might cause deformed landforms. Our materials for this lab are found on page 75. Our procedures for this lab are found on page 77 to 82. For our data, you're going to see some different video clips of us using the plate models, and you're going to write down some observations you made of convergent plate boundaries, divergent plate boundaries, and transform plate boundaries. Okay, so let's take a look at our first example. There are 4 parts, and we're going to look at each one. Okay. Make this bigger where you can see it better. All right, in this video clip, you're going to see an example. We're using foam pads. Here you see her stretching this particular foam pad, and then showing you the other top, which is more rubbery. Okay, there we have a stack of 2 of the rubbery ones and a stack of the 2 blue foam ones. Okay, so now you see the texture of the different parts that we're going to be using for our model. In part 2, we're going to be showing some different plate boundaries. Okay, here we have 2 of the same types of foam, and she is performing what we would call a transform plate boundary, where the plates are just sliding past each other. Okay, here she has 2 of the black foam pieces, and she's also going to demonstrate here them sliding past each other, which will be a transform plate boundary. Now, if she takes 2 of different kinds, there's going to be a lot more friction. And so if this was really part of the earth, then there would be a lot more ripping and tearing up of the rock. So that would be a transform plate boundary. Okay, now let's look at the next part. In this next part, she's going to be demonstrating a convergent plate boundary where the plates collide. Okay, here we see 2 plates of the same type, and when they collide, you can see how easily they would form mountains. They just pile up and would form a mountain or a volcano. Okay, now she's going to show 2 different types of plate boundaries when they collide. The denser one is going to go up under the less dense one, and that's going to be called subduction. But this is still a convergent plate boundary. And there's still going to be ridges that would develop as a landform from that. Okay, and then our last part, part 4, we're going to look at some divergent plate boundaries. And we're going to be using some pieces of Play-Doh that we have shaped into some different continents. Here we have South America, Africa, and North America as continents that we've made out of clay. And you can see that there is evidence that those 2 may have at one time fit together. and may have separated because of a type of divergent plate boundary. Also, you can see where Africa and North America possibly would have fit together. And you can also see evidence that all of those and other continents may have at one time been one supercontinent called Pangaea. Now, why would they have separated? Well, that would have been because of a divergent plate boundary. Okay, if we go back to our observations, think back to the video clip of the convergent plate boundary, the evidence from the divergent plate boundary, and some observations or evidence from the transformed plate boundaries. Okay, now those of you at home will not have a relief globe. A relief globe, well, you might have one, but it's not very likely that you have one. But a relief globe is a globe that has where the mountain ranges and trenches are on the earth. They're raised up, and you can rub your finger across it and feel the raised areas, which would be the mountain ranges and ridges. And also you could run your finger across trenches and feel an impression. So you would not be able to feel the globe, but you can look at a map, even Google a map or a globe, and you can see enough information where you can find mountain ranges, which are evidence that plates collided in the past. And you can also find areas where the earth has separated. Those would be trenches. And then you can find on North America's eastern side the Appalachian Mountain Range. And then find Japan. And the Japan Trench is right next to Japan. And then out in the middle of the Atlantic Ocean, in the northern part of the Atlantic Ocean, is the Mid-Atlantic Ridge. So even if you can't use a relief globe, you still can look at a map and locate these areas and see evidence of them. All right, on the vocabulary, most of your vocabulary words are found in the dictionary here, but there are a few of them that I have given you the definitions here because the correct definitions are not in the dictionary for what we need. So you can pause the video and use those definitions to help you complete your lab report. And then at the end, write your conclusion. Your conclusion should state what happens at the different plate boundaries. And if you have any questions or comments, please just message me. I'll be glad to hear from you. I hope you have a great day.